Hello all, welcome to Stats Cosmos. Here we are finally going to conquer the topic of hypothesis testing. It's one of the most central things that students have in statistics courses. In hypothesis testing, there are going to be some cases when we are talking about the parameter, non-parameter, etc. And there are going to be some cases when we have small samples as well as larger samples. In those different cases, we are going to use different distributions, slightly different techniques to get there. But the overall idea of what a hypothesis test is the same for all these kinds of problems. In this video, I am going to briefly go over the essentials of hypothesis testing. First, let us try to know what is hypothesis. A hypothesis is simply a claim or statement about a population parameter, such as the population mean, population standard deviation, population proportion, population variance, and so on. In inferential statistics, we study a sample or samples and use the results to generalize on an entire population or populations. Suppose we make a claim that the average age of all college students in a locality is 21, which we write as mu is equal to 21. Since this hypothesis contains equality, we refer to it as the null hypothesis and represent it by H0. The complement of the null hypothesis is the alternative hypothesis, represented by H1 or HA. In this case, the alternative will be that the mean is not equal to 21. We use this hypothesis for two-tailed tests because the alternative basically means that the mean could be less or greater than 21. Suppose instead we want to test if the mean is less than 21. Since this statement does not contain equality, we will assign it to the alternative hypothesis, and the null hypothesis will be the opposite. That is, mean is greater or equal to 21. And if we are testing if the mean is greater than 21, that will be the alternative hypothesis, and the null hypothesis will be mean less or equal to 21. These two are hypotheses for one-tailed tests. Here, the left-tailed test, the alternative hypothesis has a less than sign, and for a right-tailed test, the alternative has a greater than sign. Note that the alternative hypothesis determines the tail of the test and never contain equality, and null hypothesis always contains equality. In fact, some only use equal sign for the null hypothesis. Now, when we conduct hypothesis tests, we are primarily trying to decide whether or not to reject the null hypothesis. If we reject the null hypothesis, we'll say we have enough evidence to support the alternative or to say that the alternative is true. If we don't reject the null hypothesis, we will say that we do not have enough evidence to support the alternative. We usually do not say that the alternative is not true. We only say that we don't have enough evidence to support it. Now, to determine when to reject H0, we select a significance level alpha. Generally, 5% or 0.05 is the commonly used alpha value. 0.10 and 0.01 are also oftenly used. The significance level helps specify the size of the region where the null hypothesis should be rejected. We call that region the critical or rejection region. For two-tailed tests, alpha is divided by 2 into both tails. So we reject the null hypothesis in the tails and we do not reject it in the middle. For one-tailed test, alpha is not divided. So for the left-tailed test, the rejection region is in the left tail and it is in the right tail for the right-tailed test. Once the rejection region is set, We then calculate the test statistic. If the test statistics falls in the rejection region, we reject the null hypothesis. Otherwise, we fail to reject it. And here are the steps involved in hypothesis testing. First, collection of data, stating the hypothesis, selecting the suitable test statistic, calculating the corresponding test statistic, and finally taking a statistical decision whether to reject the null hypothesis or to accept the null hypothesis. This is all about today's introduction about hypothesis testing. Let's meet in the next video with few examples for hypothesis testing. Thank you so much all for watching this video.